2024 A-Level Combined Mathematics Paper 1 Part B, question number 13, Part C. Parts A and B of this same question were discussed in previous videos, links in the top right. Part C of this question has to do with the Moivre's theorem. The question says, express root 3 plus I in the form of r times cos theta plus I sin theta, polar form, where r is greater than 0 and theta some angle in between 0 and pi by 2 radians. It then says, using the Moivre's theorem, show that root 3 plus I raised to the power of 24 divided by 2 to the power of 23 times 1 plus I is going to be equal to 1 minus I. Now to start off with this question, we need to convert this into polar form. Now as we know, if we have the polar form r times cos theta plus I sin theta, the size of the number is going to be equal to r. And therefore if we take the modulus of this number right here, we are going to directly get the value of r. Considering that the modulus of root 3 plus I is going to be equal to the square root of root 3 squared plus the coefficient of I, which is 1 squared, which is going to be equal to the square root of 3 plus 1, which is going to be equal to the square root of 4, which is 2. Therefore, the size of the number, or r, is equal to 2. According to this, if we want to convert this number into that form, we need to take a 2 and factorize it out as the value r. Now we can see if we do that, we're going to get root 3 plus I equal to 2 times, and if we factor that out, we're going to be left with root 3 divided by 2 plus 1 divided by 2 I. So this is what we're going to get if we factorize out the radius, which is going to be equal to 2. Considering that, we can see what we're left over with is cosine theta plus I sin theta, where cosine theta is equal to root 3 over 2 and sin theta is equal to 1 over 2. Now as we know, the angle pi by 6 or 30 degrees is going to be satisfying this, because the cosine of 30 degrees or pi by 6 radians is equal to root 3 over 2, and the sine of the same angle 30 or pi by 6 radians is equal to 1 over 2. Now therefore we can convert this into 2 times cosine of pi by 6 plus I times sine of pi by 6. Accordingly, we can see we have converted into the form r times cosine of an angle theta plus I times the sine of the same angle theta, where r is equal to 2 and theta is equal to pi by 6. And you can see r is greater than 0, so that works, and theta is in between 0 and pi by 2 radians, so that also works. So therefore we have our form 2 times cosine of pi by 6 plus I sin pi by 6 for root 3 plus I. Now after this, what we need to do is to use De Moivre's theorem to show that this is equal to 1 minus I. Now, De Moivre's theorem states, if you have a number z which is of the form r times cos theta plus I sin theta, then z to the power of n is going to be equal to r to the power of n multiplied by, and here's the important part, cosine of n theta plus I sin n theta. This is the important part that we have in De Moivre's theorem. The angles are multiplied by n and the size is increased to the power of n. Now according to this, if we consider the expression that we're given, which is this expression here, root 3 plus I to the power of 24, which I'm going to write as root 3 plus I to the power of 24 divided by 2 to the power of 23 times 1 plus I, we can see we could substitute in root 3 plus I for this value that we have, 2 times cosine of pi by 6 plus I sin pi by 6. So we can substitute and write 2 cosine pi by 6 plus I sin pi by 6 all raised to the power of 24 divided by 2 to the power of 23 times 1 plus I. Now we can see in this case, we have a number on the form r times cosine theta plus I sin theta raised to a power n. Now according to this, if we use De Moivre's theorem, we can see the size, which is 2, is going to be raised to the power of n, which is 24. So we have 2 to the power of 24. But considering the inside part, the angles are going to be multiplied by 24. And therefore we have cosine of 24 times pi by 6 plus I sine of, again, 24 times pi by 6. So we have this. Now this is divided by 2 to the power of 23 times 1 plus I. Now considering this, we can see the 2 to the power of 24 and the 2 to the power of 23 on the denominator will cancel, leaving us with just 2 to the power of 1, which is going to be 2. And then we have cosine of 24 times pi by 6, which is going to be cosine of 4 pi, plus I sine of again 4 pi, divided by 1 plus I. Since this 2 to the power of 23 is gone, since we cancel all of it out for this power right here. Now due to that, we can see we're left with all of this stuff, and if we substitute in cosine of 4 pi and sine of 4 pi, cosine of 4 pi is equal to 1 and sine of 4 pi is equal to 0. So therefore we get 2 times 1, since this part here is 0, so we have 1 plus 0, which is 1. So 2 times 1 divided by 1 plus I. Now in order to get rid of the denominator, which is a complex number, what we need to do is to multiply the top and the bottom by the complex conjugate of that complex number. Since if we do that, a number times its complex conjugate is going to be equal to a real number, and therefore the term in the denominator will no longer be a complex number. So doing so, we can see we need to multiply by the complex conjugate of 1 plus I, which is 1 minus I. So therefore we multiply the top and the bottom by 1 minus I and divide by 1 minus I. Now considering this multiplication, we can see on the bottom we're going to get 1 plus I times 1 minus I, which is going to be difference of squares. So 1 minus I squared, and then on top we're going to have 2 times 1 minus I. Now considering the terms here, 1 minus I squared is going to be 1 minus I squared is negative 1. So we have 1 minus negative 1, which is going to be 1 plus 1, which is 2. So therefore we have 2 times 1 minus I divided by 2. The 2 and 2 cancel, leaving us with just 1 minus I. And therefore we can see the final answer that we get here is in fact 1 minus I. And therefore we can see when we solve this, we get 1 minus I, and that is the final answer to this question. So now finally, now that we're done with the question, let's discuss the marks awarded for this question. So at the start of the question, when you find the modulus of the value root 3 plus I and find that it's equal to 2, and therefore you divide and multiply by 2 in order to get 2 on the outside like this, you get 5 marks for that. Now after this, when you look at the inside and you see root 3 over 2 and 1 over 2 here, and you realize that you can write that as cosine of pi by 6 and sine of pi by 6 respectively, and you write it like that in order to get the form r times cosine theta plus I sine theta, you get another 5 marks for that. Now after this, when you go down and apply the Moivre's theorem by replacing root 3 plus I with 2 times cosine of pi by 6 plus I sine of pi by 6, and you substitute in the Moivre's theorem like so in order to get this expression right here, you get 5 marks for that. Now after this point, when you go down and eventually get to the point where you have 2 divided by I plus 1, and then you multiply the top and the bottom by the complex conjugate, which is 1 minus I like this, and you get this expression right here, you get 5 marks for that. And then simplifying that down, when you use the difference of squares on the denominator to get a 2 on the denominator, a 2 on the numerator already there, cancel them out, and get 1 minus I on its own as the final answer, that gets you another 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.